So now we're going to be looking at logarithmic functions. We've been looking at functions in the form y equals b to the x as exponential functions. So let's go ahead and find the inverse of this exponential function. So the first thing is to change or switch the places of x and y. So we're going to do x equals b to the y. Now the next step would be to solve for y. Now, as of yet, we do not have a method to get y out of the exponent of b. So we need to figure out how can we get x equals b to the y to be written in terms of y, which means we want y equals. Well, here we go. In order to do that, we have to use logarithms. So this definition right here says that the log base b of x equals y. Log here means logarithm. Log base b of x equals y if and only if, so let's go back to geometry days, if and only if b to the y equals x. Now remember, if and only if statements mean that I can read them forwards and backwards. So this also means b to the y equals x, if and only if log base b of x equals y. So log base b of x is only defined for x greater than 0, where b cannot be 1 and b has to be greater than 0. So remember all those restrictions we had on b? Well, all those restrictions we had on b whenever we were looking at the exponential function also apply for the logarithmic function, as well as the fact that x has to be bigger than 0. Because remember, when we're looking at logarithmic functions, doesn't matter what b is, it doesn't matter what I plug in for y, we'll never be able to reach 0. Now, the logarithmic or log function is an exponential function. It's just another way to represent it so that we can write it in terms of y. So it's very important that you understand that these two forms are exactly the same thing. This is just a way for me to write it in terms of y. So now we're going to practice going from exponential form to logarithmic form. This is going to be the very basis of this entire section, is for you to understand how to switch back and forth between the two forms. So 2 to the third power equals 8. Well, this number here, 2, is going to end up being b, where b is my base, okay? So base and then base of the log. So this is going to be log base 2 of 8 equals 3, okay? So another way to kind of say this to yourself whenever you're looking at these problems is 2 to what power gives me 8, and that's going to be 3. So 2 to what power gives me 8, and that's 3. So 2 to the third power equals 8. Alright, let's try the next one. So 1/2 to the negative fourth power equals 16. So that's log base 1/2 of 16 equals negative 4. So 1/2 to what power equals 16? That's going to be negative 4. This is going to be log base 10 of 100,000 equals 5. So 10 to what power gives me 100,000? That's 5. Okay. Next one. Log base 3 of 1 over 81 equals negative 4. So 3 to what power gives me 1 over 81. Now remember, whenever you have a negative exponent, that goes to the bottom of the fraction, so these two things are equivalent. So 3 to what power gives me 1 over 81? That's negative 4. Now these are yours to try. We put a lot of restrictions on b whenever we're looking at the exponential function. We said that b could not be 1, b had to also be greater than 0, and then when we're looking at the logarithmic function, because of those properties of b, x also has to be greater than 0. So I want us to look at what would happen if b was actually negative, and why is b not allowed to be negative. So let's go ahead and plug in some values for x, and let's pretend that b is negative 3 here. Now remember, b is negative 3, not a is negative, and then I have b is positive 3. So b is actually negative 3. So all the exponents I'm plugging in are applying to b. So when I plug in 0, anything to the 0 power is 1. Now if I plug in 1/4, that's negative 3 to the 1/4 power. Now I want you to remember what that means. That's actually the same as taking the fourth root of -3. Now, fourth root of -3, that's not possible. I cannot multiply something 4 times itself and get a negative number. So this here is not going to be possible. Now let's plug in 1/2. Remember, plugging in 1/2 is also the same thing as saying the square root of -3. Now, we do have a way to represent that. That's 3i, but we're on the coordinate grid here, and I do not have imaginary values on my coordinate plane. Therefore, this is also not possible. Okay, now let's pretend for a second that we ignore those values, that it's not possible, like 1/6, 1/8, 1 over any even number is not going to be possible, so my function won't exist there. But let's say we plug in 1. When I plug in 1, I'm going to get -3. And then when I plug in 2, -3 times -3, or -3 squared, is going to give me +9. So let's for a second just pretend that we're going to ignore these not possible values, and let's look at what the graph would look like. So 0, 1, 1, -3, 2, +9, which would be up here. Go off my grid a little bit. I want you to see that this is not looking like it's going to represent an exponential function. We know what that function should look like. It should either be exponential growth, or we should be exponential decay, or some type of reflection or translation of those. So you can see that plugging in those values, I am not going to get the exponential function that we're looking for. Alright, so now we're going to be evaluating a log, which means we want to actually find the value of log base 8 of 32. So what you're saying in your head is 8 to what power gives me 32? So we're going to take the logarithmic form and rewrite it in exponential form. So since I'm looking for what this equals, we're going to go ahead and write the equation. So we're looking for what it equals, so that's our missing value, that's our x. We're going to switch to exponential form. So 32 equals 8 to what power? So 8 to what power gives me 32? Well, 32 and 8 can be written with the same base. So I can rewrite 32 as 2 to the 5th. I can rewrite 8 as 2 to the 3rd. And remember, because of our exponent rules, if I have 8 to the x power and I write 2 to the 3rd to the x power, that 3 and that x just multiply times each other. And I can rewrite it like this. Now, if I have 2 to something and 2 to something, since the bases are exactly the same, that means that the exponents here must be equal. Okay? So that only makes sense, right? 2 to something power equals 2 to something else power. Well, since the bases are exactly the same, the exponents must be equal. So then you go ahead and you set the exponent equal to each other and solve for x. And we get x is going to be 5/3. So 8 to the 5/3 power equals 32. So remember what this means. That means the cube root of 8 to the 5th power equals 32. Now we know that's true because the cube root of 8 is 2, and then 2 to the 5th power is in fact 32. So you can check your answer there. So let's go ahead and give this a try. We want to do log base 4 of 32. We want to figure out what is the value of that. So we want to figure out log base 4 of 32. What does that equal? Well, now in your head you should be saying 4 to what power gives me 32. Now right now I do not have the same bases, and it's not possible for me to write 32 equal to some base of 4. Okay, this is not possible, which means I need to rewrite both of them. So I can rewrite 4 as 2 to the 2nd power, and 32 is going to be 2 to the 5th power. Alright, now my bases are exactly the same, which means that my exponents will be the same. So 2x will be equal to 5. And then I can go ahead and solve for x. So x is going to be 5/2. So let's go ahead and check our work here. So we're saying 4 to the 5/2 power equals 32. Well, that's the same as saying the square root of 4 to the 5th power equals 32. Well, the square root of 4 is 2. So 2 to the 5th power, does that equal 32? Yes, it does. Your turn. Go ahead and try to evaluate log base 9 of 27. We are unable to use our calculator to do the problems we just saw because our calculators only do common logarithms. So a common logarithm is any time I have a log base 10. So down here, whenever you see log of 6 or log of 256, what this actually says is log base 10 of 6, but we just don't write the 10 because it's assumed to be there. Okay? So whenever you hit your calculator and you put in log of 6, your calculator's like, alright, you want me to figure out 10 to what power is 6, and your calculator's doing that calculation for you. Now unfortunately, most calculators only do base 10, but we will soon learn a way to kind of transform everything into base 10 so that we can use our calculators.